Alrighty, let's go ahead and start with chapter 5, section 3. This section is going to focus on adding and subtracting fractions and fractional expressions. All right, so we start off with some kind of real world math. I guess here we got what fraction of an hour is equal to the sum of 15 and 20 minutes? So what I did here with the notes is I took a clock and kind of just divided it up into, parts that I think will help kind of figuring out this the fractional part of those minutes of an hour at least. So the first one, this first one right here, what fraction of an hour is 15 minutes? Well, I mean, it's maybe it is or maybe it isn't totally obvious, but right here, that part of a clock is 15 minutes, right? So you could tell like I have 1/4 of it, right? I have 1/4 of it. I mean, you could also just say it's 15/60ths, right? You could do that. But ultimately, that simplifies down to 1/4. Okay. All right. For the other clock right here, we want to figure out 20 minutes. So I broke up that clock. You can tell here, I, I divided it up into thirds. You can see here, every third of the clock is equivalent to 20 minutes. Okay. So I could just write that as like on the last one, I could write that as 20/60, right? 20/60ths, which comes out to 1/3 when you simplify it. Okay. All right. And so when you set up an equation here, find the LCD. So here's what we're going to do. We're going to set up our equation, which is 1/4 plus 1/3, 1/3. And now the rule is when you're adding fractions, you cannot add fractions if they have different denominators, right? This does not equal 2/7. All right. No, it does not. It does not equal 2/7. You know, sometimes I had a math teacher that said this, which was, if it seems too easy, you're probably not doing it right, which, doesn't give a lot of credit to math because math can be somewhat challenging, I know. But yeah, that's not the way this is done. So we need to find the least common denominator here. So, which is the same thing as finding the least common multiple. We're going to find the LCM of the denominators. That is what we're going to do. All right, so we're going to list out the multiples of 4. How many do you have to list? That's a good question, right? I mean, there is no right answer to that, I guess, but I guess enough. And if you need to write more, keep going. Sometimes people only write so many, like I only wrote 7 multiples there of 4. And sometimes what people see in front of their face, they just think, oh, well, I don't see a common denominator here because it doesn't exist. Well, maybe because you didn't go further or far enough. I'm sorry. If you didn't go far enough with your multiples, then yeah, you're not going to see it. It's not going to exist because you're just not going to, you just don't see it in front of your face. So I think the point I'm trying to make here is just be persistent. Just keep at it, keep writing down multiples, and you'll eventually get there. So I'm going to write down a bunch of multiples of 3. Okay, and I know you probably see it already. Maybe you do, maybe you don't, but you might see it. I see it. So the LCM of 4 and 3 is 12. They both have a 12 in common. They both have a 24 in common as well. Actually, I didn't go that far with 3, but if I went one more, there you can see the 24, right? But the lowest common denominator, right? The least common denominator is 12, okay? So what we want to do next is we want to rewrite the fractions with the LCD as the denominator. All right, now the tricky part with doing this is that you have to change the numerator. You have to change the numerators proportionally. We cannot just stick the old numbers up there and just say, yeah, that's okay. We've got to change them proportionally, meaning like how many 4s, right? How many 4s make 12? Well, 4 times 3 is 12. And the reason I'm saying that is because this was a 4 before. So that's what we're going to do here. We're going to do 1 times 4, which is 4. So that's 4/12 right there. All right. What did I just do there? Let me try that again. Not 1 times 4, 1 times 3. There we go. That is going to be a 3. Pardon me. All right. And then this denominator was a 3, so we're just basically asking ourselves how many 3's make 12, which is 4, right? So we're going to do for this one 1 times 4, which makes 4. All right. And so the fractions add up to 7/12. And do not add denominators. Do not add them or subtract them. 7/12 is it. 3 plus 4, leave the denominator the way it is. All right. All right, part B, using commutative property for fraction problems. I think this happens every so often. You don't see it a ton, but I think it is a useful thing to kind of have in your toolbox, in terms of things that you want to know how to do. And for this one, commutative property basically states that you can change the order, right? You can changing the order of an addition problem or multiplication problem does not change the answer, right? In this case, it does not change the sum. So what we could do is we could take this, we could take this term right here, we can put it here, and we can take this fraction, put it there, and change the order. And the reason for that, if you notice here, the reason for that is now if you look at these fractions right here, they have the same denominator, right? And that's a good, you want to add fractions with the same denominator. All right, let me go ahead and write down that 5/9 that moved over. Okay, and then, like right here, so if I add these, I'm going to kind of put that there. -3 plus 7, that's what we want to add left to right here. So -3 plus 7 is 4. All right, and don't add the denominators, we get 4/4, which is essentially 1, right? Isn't that just 1? That equals 1. So all we have to do is add 5/9 to that, and that just becomes a mixed number. 1 and 5/9. See? So I know that was kind of by design to make it a little bit easier, but that you can see, like if you move fractions, if you put fractions together that end up having the same denominator, that definitely makes it easier to add them because you want them to have the same denominator. That's the key. That's the goal. All right, now like right here, it's going to be a good idea to just move this over here, right? And move this over here, just like on the last one. So we're going to do 3/5 right here, plus 4/7. And this is basically a carbon copy of what we just did. All right, so when we do this, we get 5/5. 5/5 equals 1. And what do we get? We get 1 and 4/7. I know that's very convenient the way that came out, but I think that's a good kind of example there of why commutative property could kind of, be an advantage to know how to do. All right. All right. So this next one right here, let's actually start working on some problems here that have unlike denominators, okay? So, all right, so we got -2/3 minus 1/2. All right, so we need to have the same denominator. All right, so the LCD, the least common denominator of these, is 6. Right? 6 is a multiple of 3, and 6 is also a multiple of 2. 2 times 3, right? Sometimes people just tell me, I just multiply. You can multiply the denominators and you can get the LCD. That sometimes works, sometimes it doesn't. It kind of depends on whether the numbers have factors or not. But yeah, that works in this example right here. All right, so you want to make equivalent fractions. Now remember, you cannot just bring down the old numerators. That does not work, all right? Sometimes it's the same denominator, same numerator, I should say, because the denominator didn't change. But if the denominator did change, we have to look at it as a change, that it changed proportionally, okay? So like right here, how did we get from 3 to 6? Well, we multiply by, oops, I wrote 3. We're going to multiply by 2. We're going to multiply by 2. So that is what we're going to do. We're going to do -3 or -2 times 2. -2 times 2 is -4. Okay? Because this told us what to multiply this numerator by. Okay? You see how that works? And we're going to do the same thing here. We're going to look at, okay, what are we multiplying the 2 by here to get 6? Well, we're multiplying by 3. So that's what we're going to multiply the numerator by. So we're going to multiply that by 3. Okay, and so now we have our like denominators, which means we're all set to add or subtract the numerator. So we've got -4 minus 3. Now keep in mind, I'm going to write it like this so you see it. -4 minus 3, I'm going to write it over 6. Now another way to think of that is -4 plus -3. And that makes -7. So that is what it comes out to. So -7 over 6. And if you want to write it as a mixed number, it's -1 and 1/6. Both are correct. Okay, and this next one right here, we're going to find the LCD. Now the LCD again, so, just think about this. Like if 2 and 5 don't have any common factors, a lot of times it's a little bit of a cheat or a math hack, I guess you can call it. But if they don't have any common factors, you can multiply them and you're going to get the LCD. That will work. All right. It doesn't work every time, but if they don't have any common factors, you can do that. Alrighty. So now let's look at, okay, so how many 2s make 10? Well, that's a 5. We're multiplying by 5. So that's what we're going to multiply 1 by. So 1 times 5 is 5. Okay, and then we're going to look at 5. How many 5s make 10? Well, that is multiplying by 2 right there. So you're going to multiply this by 2. So -2 times 2 is -4. And there should be a sign here, by the way, minus. All right, so now I'm going to write it. I'm going to do kind of what I did in the last one. So I have 5 minus -4, right? There's the minus, there's the -4, all over 10. Now 5 minus -4 really means 5. It really means 5 plus 4. And 5 plus 4 is 9. So you got 9/10 right there. All right, let's go into the next one here. Just have a lot of examples here. I find that, middle school, high school, college people struggle with adding and subtracting fractions quite a bit. It's a lot of steps. There's a lot of things that can go wrong. So it's a good skill to know how to do. I think the nature of fractions being kind of abstract makes it a little bit harder, but it just takes practice. Just keep working at it. You'll get it. Keep working at it. So this one has a common denominator, least common denominator of 15. Okay, and then we're just going to look at all right, so how many 5s make 15? Well, that's 5 times 3. So we're just going to do 1 times 3, which is 3. Okay, how many 3s make 15? Well, that's multiplying by 5. So we're going to multiply -2 times 5, which is -10. -10. All right, so now we're ready. So just do 3 plus -10. 3 plus -10, which is what? -7, right? That's -7. So there's your answer, -7 over 15. Remember, do not add the denominators. Just leave the denominators the way they are. One example that kind of shows you why you shouldn't add denominators is like just think of 1/2 plus 1/2, which is a really easy problem because we all know that 1/2 plus 1/2 is 1/2, right? So if we make the mistake of adding the denominators, look what happens. What happens? We do 1 plus 1, which is 2, and then 2 plus 2 is 4. See, we get 2/4, which guess what? That's 1/2 again. So you could tell right there with that example that adding the denominators was the wrong thing to do, right? That was a bad idea, right? We ended up with 1/2. Well, we obviously should have ended up with 1/2. Okay, next one right here. Now we've got denominators that have a little bit of algebra, or expressions, So the common denominator here, now if you do 4 times 8, that's 32, but that's not the least common denominator. The least common denominator is actually one of the terms. It's actually 8x, right? The LCD can actually sometimes be one of the denominators, which happens a lot. That happens more than you think. Okay, so it's 8x. So now what we're going to do is we're just going to look at what we multiply by. So 4x times 2, right? So we're going to do 2 times 2. That makes 4. All right, and then we're going to do, all right, 8x. Now for this one, 8x is being multiplied by 1. So when you multiply by 1, the denominator or the numerator does not change. So it just stays with 5. See, that's an example right there. As you can see right here, this is 5 over 8x. This is also 5 over 8x. That's unchanged. You see, that's unchanged. So if the denominator doesn't change, well, the numerator is not going to change either. All right, so this one's all set to put together. So 4 plus 5 makes 9, and you get 9 over 8x. And that's good enough. All right, next one here. This is another one where the LCD is actually one of the numbers. 15 is the common denominator, 15. Because 15 is a multiple of itself. Think of it that way. 15 times 1, right? A number can be a multiple of itself. That is always going to be true. And 15 is a multiple of 5, 5 times 3. All right, let's do what we have been doing. Let's kind of compare here. So 15 times 1. So this is unchanged. 2x times 1 is 2x. All right, now this one is going to change. So we're multiplying 5 times 3. Okay, so 5 times 3. So we're going to do 3x times 3. Now 3x times 3 is, we're just going to multiply the 3's. Don't worry about the x. Just kind of attach it on there. You get 9x. All right, so it's 2x plus 9x, which makes 11x over 15. All right, and on this last one right here, the common denominator is 20. The least common denominator is 20. 20 is a multiple of itself, and 20 is a multiple of 10. All right, so 10 times 2, right? That's our multiplier. So we're going to do negative 3x times 2. Negative 3x times 2 is negative 6x. All right, now 20 is multiplied by 1 to make itself, right? So you're going to multiply 7x times 1, which is unchanged, 7x. All right, so what we have here, we have 6x minus 7x. 6x minus 7x is going to be negative 13x. Oops. So negative 13x over 20. And just to let you know, I know I've talked about this before, but just so you know, it's a good reminder. Remember the negative, I can kind of do this with my iPad, but the negative, remember, can kind of float around. The negative can be up in the numerator. It can be directly in line with this fraction bar. This is also called a vinculum, if you ever have a trivia question or something, but that's called a vinculum. Or it can be in the denominator. So it can kind of float around. It can be in the top, it can be in the bottom, or it can be right in the middle. All right, doesn't matter. And I think you've heard me say this before. If you've watched all my videos, I've always said that I preferred it in the numerator. I just think that's a better place to keep it because that's, especially when you're dealing with fractions, that's where all the math is that you're doing. You have to do all the adding and subtracting. Ultimately, you're not adding or subtracting the denominators, right? You're leaving those the way they are. So that does it for this one.